Hello and welcome to our presentation of Audio4All, an embedded solution to digital music creation. This presentation gives a general overview of our project. If you found the topic interesting, please check out our other videos on specific audio signal processing and machine learning implementations used in our project. We have 5 team members. Jonathan handled all of the enclosure design as well as the design of the website. James took on the responsibility for the entire machine learning portion of our project. Christian, TJ, and myself implemented the audio signal processing for the project, and TJ and myself designed all of our hardware.
Our ultimate goal for this project is to create a fully embedded and closed system digital music creation platform that has resources that can be utilized by all levels of musicians. Our system includes a custom digital music instrument to act as an input controller for users that's connected to a real-time low latency audio engine implemented in Beagle RT C++ API. We wanted our system to be as accessible as possible and allow it to connect to any digital audio workstation by outputting the audio directly. Furthermore, we implemented a machine learning chord progression recommendation system that uses both simple and complex models to allow users to follow more classic chord progressions, or the system can provide more experimental chord progressions that can prove beneficial to a more trained ear. Our complete system is also 100% embedded, so there is no need for any external computers or processors to access all of its functionality.
Shown on this slide is a high-level system diagram of all the components in our project. At the center of our project we have Bella, which hosts the main audio engine for the entire project. It receives all note control signals from our custom input controller as shown. The Bella interprets what notes have been played and sends it to the NVIDIA Jetson through the UART protocol. The Jetson then recommends chords to the user by toggling LEDs on our input controller, and these LEDs are toggled through the I2C communication protocol. The Bella also outputs audio directly to Raspberry Pi, running a digital audio workstation for song creation. Offloading audio production to another device allows for audio rendering while preserving the real-time capabilities of the Bella.
This slide shows the overall design of our input controller. On the bottom, we have laid out 25 keys in a similar fashion to standard piano layouts as the primary input for users to record music. Next, we have the Rotary Encoders in purple and the Trill sliders in blue. These sensors are used to create effects on original sounds and apply filters to help music sound more professional. In yellow, we have the digital buttons, which help control the behavior of the controller and allow users to record small sequences to play back later. Our last sensor is the circular Trill sensor in red, which allows users to adjust system settings like the volume or the instrument to be used.
The big board provides the primary input to the Bella, which is the actual triggering of the notes. The board contains 25 force-sensing resistors for note input. The footprints for each of these sensors were designed for natural playing sensitivity, since the space and trace of the sensors directly controls their force versus conductance curve. Each sensor routes to a header that directly connects to Bella through a ribbon cable, as well as a teensy microcontroller that communicates with the Jetson for chord recommendations using the I2C protocol. The conditioning sensors for the FSRs were placed on the back of the board, and a 4-layer design was used. There are 3 main components to our big board. High slew rate quad op amps were used to support 4 FSRs per op amp. The feedback resistor and FSR trace and space directly affect the conductance versus force curve of the sensors. A voltage averting IC is used to provide the negative voltage required for a chosen op amp topology, which utilizes dual channel power supplies. Each op amp power input contains bypass capacitors for noise removal. Shown here are the preliminary designs for our input controller enclosure. We chose to model the enclosure after classic analog synthesizers from the mid-20th century to achieve a retro look that can be printed on a standard budget 3D printer while still accommodating all of our hardware. And here's a closer look of what some of the hardware will look like inside of the controller. As stated previously, all control signals from our custom input controller directly control all audio DSP tasks on the Bella, our chosen audio platform. Now, if you're interested in hearing about specific audio signal processing techniques and how each sensor interacts with Bella from an audio perspective, please check out our presentation on audio signal processing. As shown earlier in the system level diagram, machine learning models running on the Jetson recommend chord progressions to the user, and these recommendations are made available through the blue LEDs above each key. If you're interested in seeing how we used machine learning on the Jetson to recommend the chords in real time, please check out our machine learning presentation.